All right. Can I just get the consensus? We are okay. We like this classroom, right? We don't need to change further. Am I right? Any objection to this? No, good. And we're gonna see on Thursday in the same building but different room. I think it should be very compatible setup, so we should be okay. Okay, awesome. We're gonna stay here. And let me start with some quick announcement. I think the most important thing for you guys to do is please go to that survey on the e-class and suggest your programming test time. I think I will try to allow you guys to actually change your mind to choose a different time if you want to. I will also maybe make the result available to everybody so you kind of know what your classmate may be available at. So you may change your mind accordingly. So far, it seems like the 2 p.m. to 4 p.m. around that range on Saturday is our most preferred. It seems like. But we're going to see. But if you haven't done your survey, please do so as soon as you can. And office hour, you can see on the syllabus, we haven't covered too many things yet. But once we get closer maybe to the quizzes, you might have more questions. Okay. All right, let me just start by referring to the only diagram that we actually went over last time, right? What I want to point out is you want to always remember for a compiler, you have the input end, you have the output end. And then you may have different semantic domains, which we definitely spent some time on last time. Just remember. I think that's basically what we talked about last time. And of course, we also gave you a list of software engineering principles like information hiding, modularity, and etc. I will do that quick review or quick introduction after the reading week when the project is released. At this point, they are not so relevant just yet. Okay. Any concern, any questions before I start with today's lecture? Good. So today, the plan, I definitely want to finish the introduction about walking you through all the terminology about compiler. I want to give you 2 examples about the compiler. The first one is more the conventional one. The second one is more modern one, like a more modern usage of the compiler. We'll see. And by the way, the slides have been revised a bit since last week. I'm going to post the most up-to-date version, maybe tonight or tomorrow. So in case you want to re-download, I'll let you know. Okay. All right, so this is what we have to learn today about the infrastructure for the compiler. Typically, we actually got 3 components inside, but let's start with the beginning and also the end. In the middle, it's a little bit flexible. Okay, if you look at that, we got the source program over here, and we got the target program here. Basically, we want to go from one language into another. And then we got a front end, and also we got a back end. Let's try to learn a little bit more about what we know about each end, the basic stuff. And then at some point, we'll talk about the difference between like a scanner, parser, and also optimizer. That's something we'll get into. The front end, well, if you look at the front end, it's exactly over here. This guy over here. That itself is some program, which will take the input program, for example, Java, and then it's going to turn that into something called IR. IR stands for intermediate representation. And for this course, you can assume IR is going to be represented as a tree. When I talk about the tree, that's the tree you learned back in 2011, the data structure course. Okay? And there is some term I want to mention right away you want to keep in mind. I'll take attendance a little bit later on the halfway through. Okay. So if you look at the same diagram over here, so now we talk about this part over here, right? So for the front end, it takes some input language, and also it's going to return some IR, intermediate representation. I first of all want to clarify this notion between concrete syntax and also abstract syntax. Concrete in the sense that it's very rigid. It has a very rigid formats. If you don't really conform to the syntax specification, you're going to get some syntactic error, like pretty much like a red underline you see in Eclipse. The abstract syntax over here is a little bit more flexible, more internal to the implementation for the compiler. So I would say here, you can think about the concrete one over here is more like, for example, let's say Java. And I beg your pardon, I meant to highlight the other one. So abstract syntax over here is more like, keep confusing myself. Concrete one is going to be the rigid one. So that will be, for example, Java syntax. For example, you can think about, let's say we have maybe class, maybe A, and then we simply got integer I, right? You pretty much know the precise syntax for Java. That's concrete syntax. What about abstract syntax? For now, you can think about abstract syntax is like the parse tree of the concrete syntax. Okay, for that one there, you're going to get that one there. You can think about it's more like a parse tree. However, I'm going to say it's more like a plus with more notion. It may be a parse tree with some additional information you will need for later transformation. Just remember, it's not just a parse tree plus some additional information you need for your transformation. Okay. So it can be transformed into, for example, you might say you have a tree. And then maybe this one here is a class. Under class, you have a name, which is A. And then under which you may have one section there under class called attributes. And the parse tree is like a B tree, right? It's not necessarily binary. Okay, attributes under which you got a list of attribute declaration, and one would be maybe integer and also I, right? Just a sketching. I'll show you a little bit more complete parse tree a little bit later. Okay, okay. That's about concrete versus abstract. So think about this one here is concrete. This one here is abstract plus some additional information. We'll do one exercise very soon. Let me go back here and then go a little bit more. And the principle about the front end for this part over here is if you're trying to make a parse tree out of this input program, you really should maintain the meaning of that particular source program. So that's why it says plus, some information. I think for now, just kind of study the definition here. I'll try to give you more example as we go, maybe a little bit later. But just remember plus the parse tree plus something else. What about the backend? It's kind of a symmetric. Let's say we got some very like a series of transformation to go from IR to another IR. It's not necessarily the case. You only got one IR. You may have multiple, which might be the case for your project later. So the backend is going to be the ending stage. Ultimately, you're going to generate the target program. For example, you want to go from Java into SQL database. So the target program is going to be the SQL code. But the input for backend is going to be the IR. So now, the symmetry you should really need to observe. For the front end, the input is concrete. The output is abstract. For the backend over here, the input is abstract. And the output over here is concrete, right? That's kind of symmetry you want to observe. That, in some way, is a very simplified version of the story because normally, inside over here, you might have as many IR transformation as necessary, depending on what kind of optimization you may want to do. So I'll show you the simple case with just one optimizer. But before that, I would like to do a little bit of exercise together with you. Okay, let's say this. Let's say I want to build not just a single compiler, let's say multiple compilers. Just make it a little bit easy conceptually. Let's say I want to build one compiler to go from Java to C, another one C# to C, Java to Python, and C# to Python. How many intermediate representation do I really need to really build a compiler? Yeah. You think about 2, and why 2? Which 2?
So for the first one, you're going from Java to C, you're converting Java to machine instruction, and then in the second one, you're going to be converting machine instructions back to C.
Interesting. Let me just write down your solution, which is very interesting. By the way, this particular exercise over here, there may not be like a right or wrong solution. I'll just try to give you some feedback, and I'll give you my version of solution as well. Okay, let me just switch over here. Okay, so your solution here, can you say it again? You are saying IR1? Okay, it's more like a Java 2 machine language. Okay. Okay, kind of the opposite, right? Bidirectional. Good, thank you. Like a high level. Basically, your solution is about, I have 2 intermediate representation. One is like a machine representation of the source. Okay, so that's IR1 is really about given a high-level language, I'm going to have some machine, like a machine instructions, like what you learned in 2021. Another one is like a high level, like a Java. Okay, sure. I'll take other input as well. Thank you. Yes. You're saying there's only one IR you need, only one. Tell me one answer. You gotta make a decision. One, okay. You're saying somehow, okay. One important idea about IR over here, let me emphasize, is also on the slides. IR itself should be expressive enough. I'll put it here, expressive enough to capture or encode ideas from the possible input. That's the very important principle about IR, because whatever input you're given, you must make sure you can encode it into IR without losing any knowledge, any information. So in your case, you're saying that you just want to have only a single IR. So in some way, your answer is not clear enough to me, because you say you want to have only one single IR that is going to capture both Java and C. But what exactly is that IR? Because Java and C, they are very different languages. For example, Java supports object orientation, like classes, attributes, methods, inheritance, things like that. But C doesn't. C support pointers, which was not supported in Java, right? We also got C, right? Okay. Also, you're considering this. Okay, I believe in C# you can also do pointer-related stuff as well. So in some way, the IR over here, it should be more clear about what exactly the feature it will be covered from the input, basically Java and C#, right? Yeah, that's something you can make it vague, but I think it should also be clear enough, right? You want to be clear. You want to make too many redundant features in the IR. It should be just enough, just for the potential input. Yeah. Okay, so you're saying somehow you're getting Java, let's say, in the input, and then you somehow will turn Java into the first IR. Is that what you're saying?
No, I'm saying IR, because, for example, you can take, if Java doesn't really have objects.
No, they don't.
But, when you do object references, they're internally pointers.
Yeah,
Break that open, and your IR could just point.
Yeah. Yeah, one potential problem for this, you're saying that somehow when you are getting this Java here, you're doing some very complicated translation from maybe Java classes or objects into the pointer structure as the IR. Not really. So somehow you want to keep track of the pointers, and then that's some system you have to implement. Okay, we can maybe talk about how you might do that specifically. But my point is, having a single IR does not necessarily capture the essence of both Java and C#. It might be nice to think about what unique features you might have in those two languages, and then just separate them. That's my point. Yeah, we can talk about your IR specifically. Maybe it will be a nice solution. We can talk about it. Okay. Any other thoughts you want to share? Okay. I think I haven't really given you enough information about IR so far. I just want to just brainstorm with you about how you may want to translate from something concrete into something abstract. Okay, let me give you one possible thought, which I included in the slides. I think my exercise here could have been also, from Java. Well, thinking this way, for both Java and C#, think about their language structure over here. Actually, got two parts over there. One is about the procedure part. That's basically just about sequential composition of the machine statements. If statement, variable, assignments without any OO stuff. The other part is just about OO. So you actually got two parts over here. So what you can potentially do is you actually have two IR. They kind of work together. One would be just about the procedural part. The other one will be about the OO. And then they can be another way too. Of course, if you want to combine them together into a single IR, not as clean. You want to have separated, like two packages. Okay. But we'll try to do more exercise on this because that's something you will need for your project. You definitely want to think about what kind of IR you would need for your compiler. But that's something we can definitely give you feedback as well along the way. Okay, but bottom line, IR itself should be as language independent as possible, meaning that they shouldn't be too corresponding to the syntax. That should be like an abstract idea. Okay. Any question up to now? Any point you want to clarify? You're still at the conceptual level, but I think it's good to mention. All right. Let me go to the next slides. Okay, optimizer. Now I'm more trying to elaborate the middle stage over here. Once we get IR, you don't necessarily let this IR, I mean the output of the front end. Okay, let me show you on the diagram over here. That might be easier. So the next diagram I got over here. Okay. The output from the front end is not necessarily the input of the back end. That's what we need to observe. That's the more complete picture. So you may just want to go from one IR into another. Possibly because maybe somehow this IR over here is not really having too much consideration for maybe the memory usage. But this one here, maybe. But that's something we'll see. I'll have one example for you about how to do the optimizer. You can get some feel about it. Okay. And we just want to find some optimal solution in general. But exactly what solution you want to find, that's something you have to define for your own application. And it could be All right, let's resume. Okay, let's go back to the slides. All right, let's now dive a little bit deeper into the scanner. So we will talk about parser much more in depth, especially how you do parsing, maybe after another 1 week or two. But let's talk about scanner. It's the easier one. And basically, there will be two categories of tokens, like a delimiter, right? So, okay, can you guys tell me why I would call things like a space, tab, new line? Oh, by the way, I'm talking about Java, because if I switch the context, for example, to Python, it might be a little bit different. Let me be clear, which your colleague correctly pointed out back in 2020. I'm talking about Java, okay? Why would I say tokens like a space, tab, and new line are useless? But for things like this, they are called useful delimiter. Okay? How about we try you this time? Yes. Yeah, that's true. Yeah, definitely. I think you're basically, that's a very valuable, let me just talk about it. So that's basically what we said before. So let's say, for example, this one here. One way to see it would be if a space over here is useless in the, well, is in some way actually it's still useful, right? You wouldn't say that's useless, but you're basically saying if we see class over here and we see a space, we know it's now time to stop and try to see what's really available so far. And if you actually see my class and then you see curly brackets, you also see, oh, it's not now time to stop, right? So in some way, these two are equally useful for that purpose. So why would I say in some purpose this would be useless? So that's not what you were answering. Yeah. Go ahead.
Spaces, tabs, and new lines are more for code readability rather than actually giving useful.
Yeah, I agree. So let me just repeat your point, and then I'll go a little bit further, and then you will lead to the answer. You're right. For space, tab, and new line, they are more like for readability of your program. Maybe you want to separate into several lines rather than having a single line of the code. And by the way, have you ever tried in Eclipse, if you try to have a program with 100 lines, try to put it into a single line with so long, I bet you it will still compile. I'm not sure if you ever tried that, but that's really what a compiler doesn't care. It's just a sequence of character. Okay. On the other hand, for these guys over here, they do have a meaning over here. Or to be a little bit, can you actually relate useless and useful thing into parse tree? Yes. Can you, what you said before was definitely right, but can we say, can you somehow distinguish between useless tokens and useful tokens in terms of the parse tree? No, they wouldn't. Yeah, that's exactly right. Good. So the answer is, for useless tokens, they do not appear in the parse tree. For example, if you look at the parse tree that we built before, for example here, right, over here, did you see the, for example, the space over here, oh, sorry, the space over here, did I put it as part of the parse tree? Not really. So that's why I said that token there is useless. So any token like a space or new line, they do not need to appear in the parse tree for further analysis. On the other hand, sometimes maybe it will be useful to actually have these, maybe. Okay, good. Okay, it's really important to know why I call it useless versus useful. And also it could be an identifier, as I said, and also it could be for a keyword, and also for a number, okay, and etc. Important question. How do you specify the acceptable pattern of the characters for a token? What kind of formulation would you use that you learned before in 2001? State machine is good. What about the textual thing?
Regular expressions.
Awesome. Regular expression, yes. However, we know that regular expression and state machine, they both accept regular language only, right? So they are kind of equivalent. What we will learn starting from Thursday is to review those concepts and make sure you're okay. And then we'll talk about briefly how you can implement the scanner. Okay? And regular expression, awesome. And quick quizzes for you guys. What will be the regular expression for while? The keyword.
Would it just be while within square brackets?
even easier. Just while. Yeah, because it has to be spelled exactly like that. Otherwise, you should be rejected. Good. What about this guy here? Identifier. Just sketch the idea. It doesn't need to be 100% correct. Say that again, sorry. Backslash, what was backslash W? W stands for? Oh, ASCII character. Well, can you have a Java identifier starting with @ ? Can you? I'm not sure if you can. Well, for example, let's say here, right? So in Java, I'm pretty sure you cannot have an identifier like this. Can you? I'm not sure if you can. I don't think. But you cannot. But I can have, for example, A234. That's okay, right? For example. Okay. Let me just show you the regular expression. But you just want to know, what can start a regular expression. The first character is always important. Okay, sorry. So that could be one possibility over here. It's not exactly correct because I only including alphabet to be the first character, just as an example. You may want to include possibility of, for example, underscore. That's maybe it should be included. After that, what does star really mean? Do you guys remember? 0 more occurrences. Good. What about plus? 1 or more. Awesome. I think in some tool they also support question mark. 0, 1. Good. But we'll see that later. Okay, white space, just for your information, that one is to say either like a square bracket, as you mentioned before, we got either a single white space, tab, carriage return, as many as you like. At least one. Okay? Just for regular expression. Okay? And I would say for regular expression, when you do the tutorial and when you do the project, right? That's kind of the stuff I don't really memorize myself. Normally, if I really forgot about how to specify that, I'll just Google, okay, to see how to do them. So they are rather routine. So there's no point to really waste your time figuring out exactly how to write it. Okay, that's good. And for parser, okay, we got syntax tree. Okay, let's see. Okay, we talk about analogy. Good. How